So here we are at the drill press. And I might use 2 drill presses for this demonstration, but we're going to start here. The reason why I chose to start here is because we're going to need to adjust the speeds. And the way to adjust the speeds on this drill press is with this pulley system here. Okay. So currently we are on the bottommost pulley. And if we look up here at this chart, all right, we're going to see that chart. We've only got a certain amount of pulleys to choose from. 1, 2, 3, 4, 5. We have a 1725 motor. Okay, so it gives you some rough speeds on the drill bit diameter here and the type of material. But for right now, I want to ignore that. All that's going to do is prove that what I'm telling you is accurate. Okay, so we're in this chart field. All right, and if you look, we've only got 5 different speeds to choose from: 400, 840, etc., all the way up to 5300. Now, if you remember what I had mentioned when we talked about drills, the bigger the drill bit, the slower the speed. The harder the material, the slower the speed, and vice versa. Well, I'll just real quick. I'll ignore this because that's not the RPM motor that we have. Okay, we're over here. Remember how I mentioned that cast could be kind of in the middle? Let's ignore these 2 columns. Okay, all right. So you can see here, if we have a 1/16 inch drill bit, we're all the way up to the fastest speed. If we have a 1/2 inch drill bit, we're down to the slowest speed. All right. Now I grabbed a drill bit. Let me lift this back up. Okay. It just fell on the floor. And this drill bit here is roughly 3/8 of an inch, and I'm going to drill a hole in this 2x4 here. Okay. And I chose this 2x4 for very specific reasons, and we're going to talk about that. Okay. Okay. So the first thing that I need to do on the drill press is I'm going to need to select my speed. I'm drilling into wood with a medium-sized drill bit. It's not giant, but it's not small either. So what I'm going to do is I'm going to adjust the speed, probably to around, I think, 840. So I'm going to move the belt up one position on that pulley system. Once again, we'll look up here. Okay, there. So I'm going to move this belt position here up 1 position to this groove right here, and that's going to make my spindle speed, or my drill bit, yes, I just introduced new words, go faster. All right, now each drill press is quite a bit different, and so you're going to need to familiarize yourself with how to adjust the speeds on each different drill press. The way that that's done is simply to ask. Okay, so I'm going to put the camera down while I do that. I think that's a pretty good shot. All right. Now, fortunately, you guys are lucky. I would almost say spoiled. You got variable speed drill presses up in the makerspace, so you're not going to have to go through this. But most drill presses are not variable speed like that, like the ones in the makerspace. and they have a belt. So it's just something that you got to get used to. The noise you're hearing is me attentioning the belt. Now I'm going to go ahead and, of course, close the cover. Okay. Put my glasses on. Got my glasses on. And, all right. So what I'm going to do here first, actually, is I'm going to drill a hole in this 2x4 without any support material. If we remember, so I have some support material. So we're going to analyze that hole before and after. First thing, though, is I want to teach you how to just use the drill press. So that's why we're going to use a couple pieces of wood. Okay. I'm going to show you on the other drill press too. This particular drill press has a keyless chuck. So I'm going to go ahead and put this in here. It has two knurled spots here, and I'm going to tighten that up. And so for this demonstration, because I want to blow out the back, I want to make sure that I don't drill into the table like some people have done in the past, probably 60 years, because this drill press looks like it's from the 60s. So, you know, it's going to go through, and I'm not going to drill on the table there. I think you can see that. Real quick, I'm going to move this. These depth stops right here, see these? So if I were to take this depth stop, right, see those nuts? They stop it from that's the drill depth. I typically don't find those very accurate, and they're good for repetitive drilling. So if I had 50 holes to drill at a certain depth, then that would be good. But for general everyday use, that's why I have it all the way up to the top. I don't typically use those that often. So let's drill through this so you can see what this process is like. I adjusted the speed, so I'm at 840. Okay, and I'm going to use the lever here to drop the drill bit in. Now, remember I said we never start with the drill bit on the material, okay, unless we're using the portable drill. Okay, so let's see. Now, I'm going to clamp this down, but believe it or not, the clamp actually isn't necessary for this. The reason it's not, well, two reasons it's not, is because it's a very soft material. It's MDF. It's not even wood. So nothing can catch really. There is no grain or anything like that. But the more important reason is that you see, and I grabbed this too, this little block of aluminum. I've got from where I'm going to be drilling to where I'm going to be holding, I've got a significant amount of distance here, and that distance corresponds into leverage. So I'd actually be able to hold it. Whereas if I were to try and drill this, okay, that would be pretty much nearly impossible for me to hold and drill this safely. Okay? You absolutely cannot hold this with your hands. It is actually impossible, and in a few minutes I'm going to show you the right way to do that. All right, but let's take a look at just the process here. I'm going to clamp this down because that is the textbook way of doing it. So I'm going to clamp this to the table, and it's not moving. You can see that. All right, so notice I turned it on and I did not start with it on the material. Now what I'm going to do is I'm going to come down here and I'm not going to go, okay, like fast. Just going to, sorry, I'm going to move my hand so my hand doesn't get in the way of the camera. That's my feed rate. Okay? See how the chips are being ejected? Evacuated up to the top because of those flutes. Okay. You stop and you wait till it stops. I'm going to show you on the other one too when we do that. I see this all the time. People using their hand as a brake on the chuck. You're going to get away with it 1 or 2 times, but that third time you're going to go get stitches at the hospital. So don't do that. Wait for it to stop. And now we can look. We can check out our hole. Remember, I was telling you about the blowout in the bottom of this hole. So that's not bad, but you can see the difference, and those are nice, and that's not as nice. Let's the reason why I grabbed this 2x4. This 2x4 is pretty much that right in that middle space to where I might not have enough leverage to drill and hold this. So anytime that I'm in doubt, I am definitely going to take the safe route, and I'm going to clamp this down onto the table here. Okay, so I'm just going to clamp this down. We're not trying to be accurate here. We're just getting a concept, okay? There's lots of techniques to be accurate and use other methods, okay? But I'm just showing you the basics, okay? So let's take a look at what happens to this hole when we drill into a 2x4 with a regular twist drill bit and no back support material. The motion that I'm doing, bringing it up and down, is called pecking, and that helps eject the chips. So there, I just went through. Turn this off in the weight. Okay. Undo the clamp. And there is my blowout. Remember I drew that on the board? Okay. See it? I think you can see that, right? It's not a good, this is a pretty nice sharp drill bit. Most of the drill bits I have I sharpen myself, so the end's pretty clean. I can get cleaner, actually. There's some fuzz on there. We're not so concerned about that, right? Let's eliminate this blowout on the back. Notice, by the way, that I'm not using my hands to remove the chips. I'm going to use a brush or a rag. Right now I have a rag. It's instant splinters, okay? And on the metal, the chips are like razor blades. They will definitely cut you. Let's see here. What I'm trying to do is I want a similar grain pattern, so I'm just going to move that up there. So you know I'm not cheating. Well, that's close enough. Doesn't matter. Blade, come on. And we're going to now drill this hole with a back support material. And we're going to see the difference here. Okay. Up. Yeah, I did that on purpose. All right, so what do I need to do? I need to adjust the table. Okay, so there's a lever back here. I'm trying to do this backwards. Okay. And I'm going to bring the table down just a little bit, because remember, I don't want to start with the drill bit on the material. Okay, so here we go. All right. Sorry if my arm got in the way. So there, I'm pecking. Okay. I felt it go through. You can even see the different color of the chips and the different chip style from the different materials. And rag here. Okay. Now, well, you get the idea. It's much better. Okay, this is a 2x4. We really almost entirely eliminated the blowout. All right, there's some of that input tear out that I was talking about with the twist drill bit on the 2x4 there. We could do this all day. As a matter of fact, if I drill into this area here where there's a knot, well, let's just do that. That area of wood, it lends itself to much more tear out. It's okay. Well, you know what? just have to get a, I don't think this is big enough. This one. Let me find a spot here so I don't have to run around the shop. We should get some tear out on that one. All right. There we go. Patience is the name of the game. Kind of do this kind of stuff. I wouldn't say entirely on purpose, but I do it on purpose, like the table, because I want you to see that if you're not willing to make these adjustments, then you're gonna be fighting your materials and the equipment all day. And I'm not kidding about that at all. Okay, so here we go. See that I want to lift? Yeah. Let's wait for it to stop. All right. So that was a really, you can see the grain, it really tore out up top there and nothing on the bottom. And that's because I have support material. Okay? Okay. So let's move on to drilling a hole in a piece of metal that I can't hold or clamp. Okay? I'm going to undo this just with, right? And I'm going to use, first thing I'm going to do is I'm going to use a special type of drill. We'll talk about this more, especially on the machines. This is called a center drill. Like I said, we're going to talk more about this. What's so cool about this is that they don't bend. And so because they don't bend like a drill bit, because this is long, right? And you can see this is a little brown at the tip, heat. They don't bend, so I'm going to get a really straight hole. So let's see here. I'm going to go and on a center drill, if we look up close here, I'm only going to be drilling in up to the right like a millimeter before the shoulder, before it starts to go straight. The shank area we don't drill in. This flute right here is just for chip ejection. And we're just going to be drilling up just like a millimeter before it starts to go straight on this angle here, okay? This is called a center drill. And don't worry, I'm just using it because this is the right way to do it right now. And we're going to talk more about those later. Only way to hold this piece of material here is to use a vise. So I'm going to go ahead and put this in a vise. And this is cool, all right? So not only now is my material being held in this vise, it has this little shelf there, so when I drill through it, I'm not going to drill into the vise or the table. But essentially what it's done too is I'm going to be drilling somewhere in this area. It is extending the length, remember? So now, and it's really heavy, so now I don't have to clamp this vise down to the table. The textbook is going to tell you that you need to. And if this vise was like this big, instead, this little vise right here, then if I were going to be doing this, then I would have to clamp this. I don't have enough leverage, okay? But here we're safe, okay? I've got enough leverage to hold on to this. So what I'm going to do, and yes, I have a plan here so we can see things get out of control a little bit as well. Not out of control as in not safe, but I'm going to lose my place where my hole is and all that, okay? I think I'm going to adjust my speeds. I'm going to make my speed a little bit faster on this because this is a 1/4-inch drill bit into aluminum, okay? So I'm going to go up to 1500. I think that should do the trick. Just a moment here. So I'm at 1500. I adjusted my spindle speed. Hey, how long did that take? Maybe 15 seconds? Okay. So you can see it's substantially faster. And okay. So here we are. And now I'm going to take this out. And I'm going to put a drill bit in here. And we're going to say, oh, it doesn't fit anymore. So I have to move this around. And guess what? Yeah, I did that on purpose. I lost my center, okay? But that's kind of the neat thing about the center drills, is that what's going to happen here, I'm going to show you a technique that it's going to auto center, okay? And so what I'm going to do is eyeball it, get it up close, and I'm actually going to make it not as close as I could, because on camera I want you to see the vise go doop when it auto centers, okay? And now I'm going to drill, what's going to happen here is I'm going to turn the drill press on. I'm going to bring down the drill bit with the lever, right? Oops. And I'm going to make this auto center, and I'm going to drill the way through this block of aluminum while I'm pecking, okay? That's what's going to happen. So here we go. Yeah. So I'm barely holding on to this. Watch the vise jump. Well, maybe it did. Well, it did. It auto-centered. And now I'm pecking. I'm pecking. Look at my feed rate. My feed rate's much slower now compared to the wood, wouldn't you say? That's because I'm on metal. Metal's a lot harder. All right, there, we're through, we're up. Turn it off, wait. Slide this out of the way, and I can take this out now. Okay, and there's our burr. Well, I could put another piece of something underneath it, but then it would be weird, you know, in this. I'm going to show you how to solve that problem right now, okay? So we're going to go over to the other drill press. I'm going to show you the other drill press. We're going to drill a couple holes, and we're going to drill a hole. All right, so here we are at the other drill press. This is a wonderful drill press. Here it is. You can see that. Okay. This is a gearhead drill press. It doesn't have a belt. The way you adjust the speeds is with these two levers right here. Currently I'm in low and high, so I am going about 120. Those are my RPM choices, 82, 120, 500, 730, etc., etc. You can see that. And it's displayed here by the lever position, okay? And the two levers are facing both that way, both this way, like that, these two levers. That's the pivot, that's the ball that you hold with your hand. And so we're in 120, okay? All right. The 1-2 position is located here on the on and off switch. This particular drill press, because it is a gearhead drill press, has a forward, and a reverse, and both speeds. So I can go 1-2 in reverse, 1-2 into forward. It's a wonderful machine. The chuck is a keyed chuck. Line that up just right. There we go. Is a keyed chuck. So I'm going to show you how to use that. Now I seem to have moved the key from last demo. Here it is. All right. And so there are these holes in here. Here's the chuck key. Okay. And I'll do it on this side so you can see what I'm doing. And loosen that up, and this countersink falls out. Now, all right. So let's see here. Let's go over the top. How about that? Let's put in a very large drill bit. So here I am. I'm going to turn this by hand until it makes contact. All right, now it's made contact. And now what I'm going to do, I'm going to do it with my, because I'm right-handed, I'm going to do it over here. I think you can see that. Here's my motion, okay? I'm going to put the chuck key in, and I'm going to tighten it up. And that is all. All right. You will see on YouTube expert machinists, better machinists than I am, go around and tighten all three of these, okay? That's bad. Don't do that. There's a few reasons, and they are that number one, okay, to get it undone, you're probably going to need a little mallet to tap it loose, okay? Number two is if it needs to be that tight, then you've got your feeds and your speeds wrong. Okay, does that make sense? If this is slipping in the chuck after just what I did, then you're doing something wrong, all right? And you're going to end up ruining your project and the drill bit. So all you need is, and put it in one, and that goes for all key chucks. Okay? It's just like a keyless chuck. You just tighten it with your hand. I mean, really, okay? And so now, obviously, we cannot hold this with our hands, especially with the size of this drill bit. So I'm going to go ahead and I'm going to put this piece of aluminum in this vise here. And this is a much bigger vise. All right, and I have about 18 inches, maybe 24 inches of leverage here. So I'm way okay. But I've got to make this slow, okay? Why? Well, because of the size of my drill bit. Remember, the bigger the drill bit, the slower I'm going to go. So I'm going to run this at about 120. Now, if there's going to be some machinists out there, it's too slow, and you know what? Yeah, you're right. I know it's too slow. It is too slow, but we're not running a production run here. We're not, slower's better. When you got to slow down. Everything that we do in the shop, when you're rushing, that's when you make mistakes and you get hurt. I just like to run it slow. Yeah, the chip has a tendency to stick more, but I'm sorry. I'm going to run this at 240. I'm sorry. That's 120. That's 240. So I'm going to be running this at 240. And 240. And you're going to see a nice big chip on a big drill bit, okay? So, here we go. It takes some substantial pressure. The drill bit might be dull. Oh, I forgot one thing. On holes this size, just a little bit of cutting fluid. I know, we'll get into all that, don't worry. Now, when a big drill bit, and we'll go to the whiteboard to analyze this, as I'm ready to pass through, we need to be extra careful, okay? And I'll explain on the whiteboard. Here's an example of our chip that we generated. This is telling me that I've got a pretty sharp drill bit. It's pretty good. It didn't take too much force, actually, especially after I applied some cutting fluid. And there's that. And take my rag here and wipe this away. What I'm going to do now is I'm going to demonstrate to you how to countersink. It helps us get on the same page about everything later. Okay. So remember that burr that we had there, and we've got one there too now. I'm going to go ahead and take care of that. And I'm also going to do it on both sides. Okay. I'm going to go ahead and I'm going to put this in the vise. I'm not going to worry about centering it. This is my single flute countersink. Ooh, I got a bigger one, but that'll just make it. Notice I left the chuck key in the chuck. That's bad. But I'm talking. It's really hard. Okay. So let's go ahead and let's countersink this smaller one with all those burrs on it. So I'm at 120 RPM. Very slow, and I'm going to auto center again. I'm just going to get it up close. See the vise move there? That's all we need to do. Just going to get this up close there. It'll auto center for me. There. Get rid of that burr there. Whoops. Do not grab it, okay? See the teeth in there? It'll eventually cut you. I promise. And so that looks pretty nice. And now we can come over here and we're gonna do the same thing, okay? No cutting fluid on aluminum. It's just not necessary for countersinking. You can see I'm a little off. Watch the vise. That, boom. Okay. Oh, whoops. I'm on the wrong side. I already did that. Just talking. All right. Let's do it again. Yep. See the vise? Okay. Just kind of tap that over there. Oops, I'm talking. Just get it close, there we go. Watch the vise move. Yep, that was perfect, okay. Turn that off. So real briefly, I'd like to talk about going through a part. Like I mentioned I wanted to do that on the whiteboard when we get to the bottom. And I also want to talk to you about drilling sheet metal because they're very similar principles. So let's move on over to the whiteboard. And almost done. Let's take a look at that hole and let's analyze what's happening there. Okay, this is really important. So here's our block of metal that we just had. All right, and as we started to go through it cutaway view, of course, as usual. It looked like this. Remember, I'm starting to go through. I'm starting to go through. Now, this, you can see the profile of the drill bit. As this continually goes through, we are losing our tip. So give me some erasing here too. Okay, give me a few seconds, a few more minutes than usual. So I can make this really clear. All right. So this is what the blue is the drill bit. It's going through. Now all of a sudden, it's starting to look more like this. We can see now. This is really important, you guys. That, and this is this is where you get hurt. Okay. This is where you can get hurt bad. Not only will your project get messed up, but like I said, you can get hurt. Because we're losing support of the entire drill tip, that the actual chip that's being generated off of this cut here, we're introducing vibration here, okay? And because of the lack of support. And that chip, because of the vibration, might not get cut. And so now we've got this dangling chip in here, okay? And what it can do is, because of the physics involved, is it's going to take your part and, right? And really, and really grab it and throw it around, because all the geometry got messed up because we're starting to break through. So it's really important that when you get to this point, that you start to go very slow. So your feed rate is extremely slow, and you're very attentive, and you are really paying attention to what's going on, okay? And I like this because this leads right into drilling with sheet metal. Typically, especially in industry and factories and manufacturing, they don't drill sheet metal. They punch it, okay? Essentially, it's impossible to get, if you take a piece of sheet metal, hang on. And here's that sheet metal, right? Do you see, it's never in contact. There we go. It's never in full contact with that cutting surface. So let me draw that. So it really is okay. This is where I don't want to ever scare you, but I want you to really, really I want you to understand this. And if I have to explain this again, I will. This is a situation here that's super, super scary. So we have absolutely no support with our drill bit into this sheet metal. Okay, we're essentially punching it, and at the same time it's in rotation. Okay, so it's really not even cutting; it's more of a tearing action. All right, and that chip, which isn't even a chip, it's just a tore out piece of metal. It comes around like that, right? It's going to get caught in that flute, okay? Like serious. Now remember I said that this piece of sheet metal, it's razor blades on all 8 sides, even though I know it's still 8 sides, right? Get it, right? 1, 2, 3, 4, 5, 6, 7, 8, and 4 really sharp corners. It's not going to cut. It's just literally going to start swinging this thing around in the drill press. All right? Now you've got basically flying razor blades. Okay? I cannot stress to you enough how dangerous this is. So that there is a way to do it safely. I'm going to show you right now. But the other thing I want to point out, and let's look at the top view very briefly. There's our piece of sheet metal, and we try and drill a hole through. Because there's no support, you're actually not going to have you're not even going to have close to a round hole. It's going to look something like that. okay? Literally. It will not be round. It'll look totally sloppy. It'll be awful. You will not be happy. It was completely dangerous. Now, let's look to see we don't have a punch and we need to drill through a piece of sheet metal. And let's do it now, so not only is it safe, but we're going to end up having a round hole, okay? I have a feeling some of you are already like, oh, I know what to do. You probably, I think you're going to get this, and that you're probably absolutely right, and you're going to support the back of the metal with a piece of wood, okay? So here's our wood. Notice I drew this somewhat large, okay? And we're going to have our sheet metal supported on here. Now we're coming down. I know before I went up, we're coming down this time. All right. And we are going to have, this is where we're going to drill our hole, right here. We're going to have a clamp relatively close to the, we're going to have a clamp. Oh yeah, and it's clamped to the table. So here's the table. Right, there's the table. We're going to have a clamp here, okay? And by doing that, remember before I said you're kind of tricking it? Well, you're not tricking it, you're just adding support. When we start drilling with our drill bit, I know you already see it. There's our drill bit profile, right? As we're drilling down, see that? We've got support, okay? And that is how you drill a hole into a piece of sheet metal. Without the wood, without the clamp, is an absolute recipe for disaster. As a matter of fact, it's so dangerous that until a couple years ago, maybe a year ago even, a few semesters ago, I didn't even show how to do this, okay? When I do it, I only use 2 clamps maybe. So upstairs in the makerspace, they know if you're going to be drilling sheet metal, you got to ask for help. I cannot tell you how dangerous this is, all right? I can't stress that enough, okay? I kind of hope you enjoyed those demos. They were our first real demos. And we'll see what I'm going to surprise you, see what we can come up with next. I know what it is, but I'm going to surprise you. Awesome. Okay. Well, take care, you guys.